find the value of x in this nice exponential equation, let's consider the value of 36. From here, you can see that 36 can be equal to 6 to the power of 2, right? So if 32 can be equal to 6 to the power of 2, that means we can replace 32 with 6 to the power of 2. So that expression will now give us x to the power of x to the power of 3, and this will be equal to 6 to the power of 2. So in the next stage, we are going to consider simplifying this. And to simplify this, what we'll consider doing is to take the cube of both sides. Now let's take the cube of both sides. The reason why we are doing this is so as to simplify this expression into a common term that can be simplifiable. And this will be equal to 6 to the power of 2 all to the power of 3. Now, in the next step, we are going to consider a law of indices. Now, in that law of indices, if I have a to the power of x multiplying y, this can be equal to a to the power of y multiplying the value of x, and this can also be equal to a to the power of x multiplying y. So if we apply this over here, let's assume that this is y and this is s. If we invert it to become this, that expression will now give us x to the power of 3 all to the power of x to the power of 3, because the external power now becomes the internal power, and the internal power now becomes the external power, and this will be equal to 6 to the power of 2 multiplied by 3. So in the next stage, we'll simplify this. If we simplify this, we'll have the x to the power of 3 all to the power of x to the power of 3, and this will be equal to 6 to the power of 6. Now we have a typical equation such that the base is same with power and the power is same with base. So how do we solve this? Now recall, in a law of indices, if I have a to the power of a to be equal to x to the power of x, definitely a can be equal to x as long as x is greater than or equal to 1. So if x is greater than or equal to 1, we can equate the denominator or the numerator. So if we do that to that equation, x to the power of 3 will now be equal to 6. Now we can simplify this in order to have the value of x. Now to do that, we'll simply take the cube root of both sides. The cube root of x to the power of 3 equal to the cube root of 6. So the cube root of x to the power of 6, this will clear this, and we'll be left with x to be equal to the cube root of 6, which can also be equal to 6 to the power of 1 divided by 3. So this is the result to that expression we have given to us up there. Now we are going to check to see if our solution is absolutely right. Now let's go back to the original question. We are given x to the power of x to the power of 3, and they said is equal to 36. Now will that give us 36? Now let's check this out. We are given x to the power of x to the power of 3, and we are told that it should be equal to 36. So if we insert 6 to the power of 1 to the 6 to the power of 1 divided by 3, will it actually give us 36? Let's check. Now let's insert the value of this is the cube root of 6 all to the power of the cube root of 6 all to the power of 3. Will it give us 36? Now let's simplify that. With this, we can see that this cube can simply clear the cube root and we'll be left with the cube root of 6 to the power of what? Of 6. Now recall that the cube root of 6 can still be equal to 6 to the power of 1 divided by 3, right? So that can multiply 6. And that expression will now give us 6 to the power of 1 divided by 3. Remember the law of indices, the power will multiply. And if the power multiply, 3 here will give us 1 and 3 will give us 2, and so we'll be left with the solution to become 6 to the power of 2. Now 6 to the power of 2, is it equal to 36? Yes, 6 to the power of 2 is 36 and 36 is equal to 36. So that tells us that x equal to 6 to the power of 1 divided by 3 is a solution that satisfies this exponential equation that is given to us from the beginning of this question. So if you enjoy this math solution, don't forget to like and share this video, and also remember to subscribe to my channel for more maths content. Thank you and bye bye for now.